What is going on, everybody? Welcome to part 6 of our deep learning with neural networks, TensorFlow, and Python tutorial series. In the last video where we left off, we kind of got familiar with our data set, familiar with our means, how we're going to go about actually passing this and creating and pre-processing this data to actually fit through a neural network. And now we're actually going to write the code that does that pre-processing step for us. So far we've done our imports, and those were explained, and we've defined the limitizer, we've explained how many lines and all that, and now we're ready to begin. So the first step that we have to do is we need to create a lexicon. So the way that we create this lexicon, again, is, at least at its very most basic level, it's all of the words that we find in our positive and negative data sets. So to start, we might say the lexicon equals, and we'll say just an empty set here. And then what we're going to say is let's say for file in posneg. That way we don't have to write the same code twice in a row. And really, this probably should just be a list. But I'm not, whatever. We're fine. This is not important for that. So then we're going to say with, and then with open, whatever that file is, with the intention to read, as f, we're going to say the contents of this is f.readLines, and then we're going to say for L, for line, in contents up to however many lines we were going to read. Up to how many lines? We're going to say all words equals word underscore tokenize L. And then we're going to say lexicon plus equals list of all. Ooh, looks like we typoed. Sure did. Nice. Autocomplete for the save there. Words. There we go. All right. So that's just going to read our data in and stuff it into a lexicon. But of course, this lexicon currently contains like copies of words and all that. And then the other question we have is, do we actually care about every single word, or do we care about specific words, or is there like some sort of range or something? And I'm going to kind of put forth that there is a range that we actually care about. So outside of this for loop, once we've populated lexicon with every word that we've come across, the first thing we want to do is we're going to limitize all of these words. In fact, we might be better off to first do. I'm going to go ahead and just limitize them first, but you'd probably want to you could chop away words first, maybe. I don't know. Because the logic that we're going to use to get rid of words, you'd really want them limitized first. Anyway, we're going to say lexicon equals, and then we're going to do this one-liner for loop, limitizer.limitize, limitizer.limitize I for I in the lexicon. Okay? So this is just our way of kind of stemming them into legitimate words. And then we're going to do word counts, w underscore counts equals counter. And then we're going to apply that counter to our lexicon. And this just gives us a dictionary-like element. So word counts might look like this, the, and the is going to occur this many times. And then, and probably occurs, let's say 25,000. Okay, something like that. Okay, it's a long dictionary-like object that it looks like this. Okay, and then what we're going to say is and in fact, let me comment that out. That redefines everything. Okay, so for w in word counts, what do we want to do? Well, we're going to say if. And then we're going to throw in some hard-coded parameters here, sorry. If 1,000 is greater than word counts W, so what would word counts on a word be? So it'd be word counts the value would be the actual count, how many occurrences did we have. So word counts W, it needs to be less than 1,000, and then we're going to say greater than 50, okay? You can kind of tinker with these values, but I'll at least explain why I'm choosing them here in a moment. So first of all, we need L2. L2 is empty for now. And then L2.append W. And then, before I forget, this function returns return L2. Okay, so this creates the lexicon. L2 is the final lexicon. But what's happening here is basically we're saying like we don't want super common words, because super common words are like the, and, of, or these kinds of words. Like, okay, so we don't care. Those words aren't going to be valuable, so those are just going to like blow up our model more than we want, right? So this lexicon is literally going to be that input vector. That input vector is going to be the lexicon in length. So ideally, we want the lexicon to be as short as possible, so that we can have a decent sized model, like in terms of like 3 layers and like, I don't know, 1,000 or something nodes or cells in that layer. So we want to be able to make lexicon as efficient as possible. So we're going to say like we don't want super common words because we don't think they're of value. But you might say, I don't know, like, because 1,000 is like 10% of the data set. So maybe 5,000 or something like that, but we'll stick with 1,000. And then we're going to say like the really rare words we also don't really care about. 50 might be, again, too big of a number for your tastes. Might be wiser to use a smaller number. But we're going to stick with 50, and we're returning the lexicon, and we'll see how that goes. But again, you can kind of tinker with this. I think, as you will see soon enough, this does not matter much. What's going to matter is something else. So once we've got the lexicon, we're ready to use this lexicon and maybe classify feature sets. So how might we go about actually classifying feature sets? Well, first we're going to have some sort of function that's going to do that for us. So we're going to say define sample underscore handling. Sample handling is going to take a sample of some kind, and it's going to take the lexicon, and then it's going to take a classification. So what is this classification supposed to be? And then we're going to say feature set equals empty. And then we're going to say with open, whatever the sample is, with the intention to read as f, contents is going to equal f.readLines, kind of like we had before. And then we're going to say for L in contents up to how many lines? So like that. So for each of the lines in our lines, we're going to say the current words, and this will be word tokenize. And we're going to tokenize L.lower. I think we'll do a dot lower here too. I'm pretty sure it won't matter, but no, we definitely want these two to be the same. That's for sure. So anyway, we'll keep that there. So those are the current words, and then we're going to say the current words is now the limitizer. Oops, limitizer.limitize I for I in current words. And then we're going to say features equals that mp.zeros, and that's going to be the len of whatever the lexicon is, which we passed as a parameter. And then what we're going to do is we're just going to iterate through our words and then set the index in this features array to 1, or we're going to use plus equals 1 because I think that makes the most sense, but it really probably does not matter at all. But anyway, for word in current words, if that word.lower is in our lexicon, well, what do we want to do? Well, we're going to say we need to find out what the index value is. So index value equals lexicon, no, jerk, there we go, lexicon.index, and then word.lower. So we're going to search in our lexicon for that word.lower, and this will return basically our index value there. And then we're going to take that index value and say, okay, great. So the features, or the feature at index value, that is going to be either equal to 1, or you could say plus equals 1. So depending on, like, if you were reading an entire like paragraph, or you were using this on like a huge paragraph or something, plus equals 1 might actually make more sense. But since we're using actually pretty small strings, this probably is going to have absolutely no impact to whether you use plus 1 or plus equals 1, especially on this data set size. I don't think it'll matter. But anyway, you could, if you use whatever philosophy you think is best. Then we're going to say features equals the list of features, and then we're going to say feature set dot append and we're going to append a list of lists, feature set, features, and then the classification, whatever that classification is. So at the end of the day, a feature set up here is going to be this huge thing that's a list of lists, where within these lists you're going to have this thing that looks maybe like this, right? This is that hot array, so to speak, that has like each index of the, like the bag of words model basically are features, and then you have the label, which soon you will see is like either a 1 and a 0 or a 0 and a 1, right? So the 0th element here is the positivity, and the 1st element here is the negativity. So a 1, 0 is a positive sentiment sample, and then a 0, 1 would be a negative sentiment sample. So that's our feature set. That's what that's going to look like. And then when everything is all said and done, we want to return that feature set. Okay. So I think we'll cut it here, and then in the next tutorial we'll go through I think we only really have like one more function, so I think I'm gonna go ahead and have us write this next function. I don't think you guys will mind. So unless we have like 1,000 errors. Okay. So what we're gonna say next is define create feature sets and labels. So far we've kind of got a high level. Some high-level functions that are going to do these things for us, but now we actually need a function that's going to pretty much actually like do it and put it all together for us. So create feature set. Yes, great. So now what we're going to do is we're going to pass positive, negative, and test size, and this will be 0.1. So we're going to say a 10% test size. Lexicon is going to be equal to create lexicon, and we pass posneg. And then our features will be an empty list. And then we're going to say features plus equals the return of sample handling. And then we want to pass in the pos.text and the lexicon. And then our classification for positives is 1, 0. I forget if I did save pos and negative text. I just want to make sure I actually saved this. Okay. And then we're going to do the same thing for negatives. So I'm just going to copy this line, paste. Neg.text 0 and 1, and then what we're going to do is random.shuffle features. So we need to shuffle these for sure, not just for like testing and stuff, but and not just for like statistical reasons, but actually for the neural network, because remember, a neural network basically, you're like, let's say everything was positive. I don't really think we've shown it, but hopefully by the end of this tutorial, or this like mini series on implementing this data and testing it, you'll see what a neural network's actually doing. And you probably will recall before, the question was, from the output of the neural network, the question was, does tf.argmax of, let's say, the output, does that equal the tf.argmax of our expectations, right? That was the final question of, did we actually get the prediction right? Now, what does this actually look like? So if we actually looked at this, like the values of output and expectations, like let's consider this case where you just have like these two output nodes. So we're going to ask, does the output equal expectations? So like, let's say we're expecting a positive. It would look, TF argmax here would be 1, 0. But the output here is actually probably more like this or something. It's probably not this big. It's more like, I don't know, that and that. Okay? And this is true, yes. Okay. But this is obviously not a 1 and this is obviously not a 0. But in this kind of one hot output structure, you just want to know what's the maximum argument, and that's kind of how strongly we feel that this is positive, right? So that's how it works. So if you didn't shuffle, basically you would train the network to pretty much try its hardest. Like if you were feeding positives and you said you wanted this, you'd basically train the network to do like this. right? And then like, I don't even know, like negative 999, right? Because the network would be like, okay, yeah, basically everything just needs to be like really weighted up this way, and like this, you would just train the network to do this. So you definitely want to shuffle the data, not just for statistical reasons, but also just because that's how the neural network model is going to work. It's literally going to be shifting the weights to try to make these argmax functions be true. And yeah, anyway, so that's why you definitely want to shuffle the features here. Now what we're going to say is features equals an mp.array features. Okay, we need this to be a NumPy array. And then we're going to say the testing size is just equal to the integer value. We want a whole number here of test size times the len of features. Okay, so it's just 10% of our features, whatever that whole number is, that's what we that's what we want our testing size to be. Now we're going to say train x equals the list of features, colon, comma, 0. This is just some nice NumPy array notation that you can actually get away with. When you say colon, comma, 0, basically let's say you've got an array and it's like a 5 and a 8, okay? And you've got like a list of these things. Let's say you got like this, okay? So features, colon, comma, 0, and like let's say you have a 5, 8, and then a 7, 9. Okay, when you do this colon, comma, 0 stuff, basically you're saying I want all of the 0th elements. So this here would be, 5, 7. Okay, and in reality, these are our actual features. So again, our feature set is like this, and then actually, and each one is your features and label, right? And then you have a bunch of these, like this, okay? And then our features, if you recall, are actually their own little array, and they're like these little one-hot arrays. I'll just do this. And then the label itself is, I don't know, 0 and 1, and so on. And so when we say we want the list features 0, we're just taking all of these, right? All of those, like the true feature sets, not the labels, okay? And we want to take those all the way up to the very end, software updates, of testing size, that integer value. So basically we want to do this for all of our features up to the last 10%. Okay, then we take this, and I'm just going to copy that, paste, and we're going to say train y equals that, only we want actually, the first elements there. And then I'm going to copy these, and then rather than train x, it's test x, and rather than train y, it's test y. And then it's actually negative testing size to the very end, so the last 10%. And then at the end of the day, we want to return return train x, train y, test x, and test y. Okay, so that's pretty much where everything's going to come together for us. I guess I need to get rid of this before that causes problems. Actually, it might not actually cause problems there. I don't know. Anyway, and now we're going to go ahead and run this bad boy, and we're going to say if name equals main. And this is just so that we could reference this later on in our script if we wanted, but if we call this script into action, it's just going to run this instead for us. And then what we're going to say is these values here equals, and then it's equaling create sentiment feature sets. So this function, and then this function we pass pos.text, pos.text, neg.text. Since we're using all these local values, by the way, make sure when you execute this script, you're executing it from that directory. Don't be executing, yeah. Anyway, pos text, neg text, and that's it, right? We just pos neg. Yeah, and the test size, we're just going to leave that because we wanted that default parameter there. And now what we're going to say is with open, and then we're going to call this sentiment set.pickle as WB, or yeah, as F rather. And what we're going to say is pickle.dump, and we actually want to dump all of these values, and we're going to dump them as a list, and we're going to dump them to obviously F. So this creates a pickle of all this information for us because we don't really, I mean, like we only need to run this function one time, or this script one time, to have all these elements, and then we can pass them through our network. So let's save this and run it and see how many errors we have. So let me try to make this smaller so I can pull this up. Cool. And so first we're going to change directory into desktop, tf-tuts. I think that's where we want to be, right? Yeah. And then we're going to say Python 3 create. Let's see what happens. Okay, triple equals. Okay, error number 1. Cancel those. Come back over here. Did we print? I wonder if we printed the length of that lexicon. I meant to print len lexicon, but I don't think I did. Yeah, I think for right above L2, it could be useful to just print the len of L2, just so you know like how big this is. Print len L2. It just kind of gives you an idea of like how large, but we didn't get any errors, and I'm assuming our pickle is here. Yeah, here's our pickle. So it's about 140 megabytes in size. So it's 140 megabytes. As you can see, like this is how you can know. So like to run this, we're going to use up 140 megabytes for sure of RAM just for this, and then that's not even including our neural network model. And that's because of the size of our lexicon for the most part. So Python 3, yeah, so we'll run that one more time. Hopefully quickly we'll see the lexicon value here, or the length of our lexicon. So 423. So that means every input vector is going to have 423 elements to it. Okay, so that's actually, you know, quite large, as opposed to like the initial string data, like opening up pause.txt, for example. Well, this first line is actually kind of long. It's definitely not 400 characters though. It's, you know, it looks like a tweet almost. And then a lot of these are very, very short lines. So not 423, and really 423 is actually pretty small overall. But yeah. So okay, so we've got everything now pre-processed. So now we're basically at the step where we were with the MNIST data set. There are actually a couple things we'll have to change in the script, like the batching and all that, because they had a nice little batch function written for us, but hopefully that will be a really easy hurdle. So anyways, we're pretty much we've pre-processed all of our data and we're ready to feed it through. So that's what we're going to be doing in the next tutorial. If you have any questions, comments, concerns, whatever, if you're getting an error here or anything like that, feel free to post below. I'll do my best to help you out. Otherwise, till next time. Maybe. I can't seem to get this to stop.